Okay, so let's start patterns and sequences. So let's say we take a number, take 0 for example, and we add 4 to 0, and then we add 4 to the next number and 4 to the next number. Then we would get a pattern like this. Okay, and if we were to take the last digit then of each of these numbers, we would actually see that there's another excuse me, pattern, or there's another pattern within another pattern within the pattern. Okay, so the last digit of this number, the first and last, 0, 4, 8, 2, 6, and then 0, 4, 8, 2, 6. So there's actually numbers repeating in blocks of 5 within this bigger pattern. Okay, number patterns are called sequences. Okay, so for example, this sequence here of 1, 3, 5, 7, 9 is a sequence, and each number's place in the sequence is its position. It's first position, second position, third, fourth, fifth. And each number is called a term. So the first term is equal to 1 here, the second term is equal to 3, the third term is equal to 5, the fourth 7, and the fifth term is equal to 9. So the number, for example, say the number in position 3 there has its term equal to 5, or the third term is equal to 5. It's the third term, but its position, it's in position 3. So let's look at the term-to-term rule. So here's a sequence here, 4, 8, 12, 16, and 20. So what is the term-to-term rule there to go from one term to the next to the next? It's simply add 4. Look at this sequence here, 30, 25, 20, 15. The term-to-term rule is subtract 5. Okay? And if we're describing a sequence, we describe it by stating the first term in the sequence and then the term-to-term rule. Okay, so for example, look at this sequence here, 3, 6, 9, 12. The sequence begins at 3 and increases in steps of 3. Another example here, the first term of the sequence is 4. The term-to-term rule is add 4. What is the second term? Well, the first term is 4, add 4, it must be 8. Okay, what is the fifth term? Well, we can just simply say 4 and 4 and 4 and 4. The fifth term is 20, that's in position 5. Okay. Let's look at this example now where we actually have a pattern of blocks. Okay, so in the example we're shown the first 3 positions and the pattern for each of those positions. Okay, so each term in the sequence is the number of squares in the pattern. Complete the sequence. Okay, so each term is the number of squares in the pattern. So in this first position, the term is 5, and there's 1, 2, 3, 4, 5 squares in that pattern. In the second term, in the second position, the term value is 8, so there's 8 blocks. And in the third position, the term value is 11. Each term in the sequence is the number of squares, so there's 11 there. Okay, and we're asked in the question to complete the sequence, so to draw the pattern for position 4 and 5. Okay, so how do we go about solving this? So the way to solve this problem is to go is to look at the term-to-term rule. Okay, so we can see that 5 to 8 and 8 to 11 must be add 3. So we're adding 3 blocks each term. Okay, and logically, if we look at the pattern here, it looks like we add 1 block into this spine and 2 at each end. So 11 plus 3 is 14. So we have 14 blocks, and we're maintaining the same pattern. And then if we add 3 onto the next term, to get the next term, then we'll have 17 blocks. So again, adding 1 block into this spine and 1 block either end of those 2 spines maintains the C-shaped pattern. So let's look at an approach now to solve repeating patterns. So we have, for example, we have a repeating pattern here made up of letters as follows. So we have A, B, C, D, E, A, B, C, D, E, A, and we're assuming that goes off A, B, C, D, E again. So what we actually have here is we have a pattern that repeats in blocks of 5. Okay, so it repeats in blocks of 5, and the question we're asked is, what would the 25th letter be way out here, and the 43rd and the 61st? What would those letters be? Given that the pattern repeats. Okay, well, the key piece of information in answering this problem is to note that how the pattern repeats in blocks of 5, and 5 is the key number. Okay, and the way we find, what block will be what block up the line is that we take the position number that we're asked for, and we divide that by 5. So these are the position numbers here. We divide by this magic number 5, and if we're to write out our sample block here, A, B, C, D, E, if we divide the position number we're asked for by 5 and we get no remainder, then that must be in an E here. Okay, so I have 0 remainder here. And then we've just marked, so we know to work these out, that remainder 4, if we divide any position number by 5 and we get an answer with remainder 4, then that means it will be a D. If we get an answer with remainder 3, the letter up the line will be a C. If we divide a position number by 5 and we get an answer with remainder 2, it will be a B, and remainder 1 is an A. And this method is a method that we use all the time, whatever the lengths of the blocks are. If it's whatever 1, 2, 3, 4, 5, 6, 7, 8. If the pattern repeats in blocks of 8, we divide by 8. This is the no remainder, 7, 6, 5, 4, 3, 2, 1 remainder that we can name what the block is. So, for example, the 25th letter will be 25 divided by 5. That's 5. There's no remainder. It's E. 43 divided by 5 is 8. Remainder 3. So that's C. And 61 divided by 5 is 12. Remainder 1. So that's here the 1 remainder. That's an A. And this method applies whether you have shapes, colours, tiles, whatever the repeating pattern is, so long as you know the magic number of the blocks of repeat. Now let's look at linear sequences. Okay, so when the term-to-term rule involves adding or subtracting a fixed number, so adding or subtracting a fixed number, it's known as a linear sequence or an arithmetic sequence. Okay, so if we look at this sequence here, it goes from 2 to 4 to 8 to 16 to 32, okay? And what's happening here is the term-to-term rule is that we're multiplying 2 by 2 to get 4, by 2 to get 8, by 2. So it's a multiplication, it's not an addition or subtraction, so this is not a linear sequence. And also, we know it's not a linear sequence because the difference between the terms is not constant. The difference there is 2, 4, 8, so it's not constant, so it's not a linear sequence. Okay. So let's see how to find any term of a sequence. Okay, we can use the nth term rule for a given sequence. Okay, and so sometimes we're given the nth term rule, and we'll be shortly learning how to generate or find what the nth term rule of a sequence is. But let's say that we're given an example where the nth term of the sequence is given by Tn equals 3n minus 4. Okay, so n is the position number in the sequence, and t is the term value. Okay, so the Tn actually stands for the term value at the nth position in the sequence. Okay, and that's equal to 3n minus 4. So the term value at the first position, n is 1, will be 3 by 1 minus 4 is equal to minus 1. The term value at the second position, n is equal to 2, will be 3 by 2 minus 4. 6 minus 4 is equal to 2. Okay? So we might be asked to, given that we've been given this piece of information here, write the first three terms and also find the value of the term at position 20 when n is 20. So I would do it like this. I would write a table of position for n, 1, 2, 3, 4, and then 20 is up here because we'll get to that. The term value, so it's done out here, so you can see the 1 slots in here for the value of n, the 2 following this formula here, and that actually equals minus 1, 2, 5, and if I put 20 into this formula here for n, I get a value of 56. Okay, so T20 is equal to 56. So is the sequence linear? Yes, it is linear because the difference between the terms is constant. From minus 1 to 2 is 3. From 2 to 5 is 3, and that will remain constant all the way up. It is therefore a linear sequence.